of the following amino acid. Shown here on the board a structure of glutamate hydrochloride. We use the symbol here Glu.HCl for glutamate hydrochloride. Glutamate has two carboxylic acid groups attached to the alpha carbon, and of course it's an alpha amino acid, so it has an amino group on the alpha carbon, and in the hydrochloride form we have a chloride ion and an additional proton on the amine group. So we have a total of 3 ionizable protons, one there, and the third one there. The molecular weight of this compound is 183.59 grams per mole. And when we do a base titration of this acid, we need to know approximately how much sodium hydroxide we're going to require. So if we first calculate the moles of sodium hydroxide, and we can calculate that if, for example, if we took a half a gram of the glutamate hydrochloride, divide by the molecular weight, that would give us the moles of the glutamate hydrochloride. And since there are 3 protons per mole of the glutamate hydrochloride, and it's a 1-to-1 reaction with sodium hydroxide, we can calculate the total moles, which would be 0.00817 moles of hydroxide. To convert that to milliliters of sodium hydroxide, we take that value, 0.00817 moles, and for example, if we were using 0.48 moles per liter sodium hydroxide solution, you'd multiply by 1,000 and divide by 0.48. That gives us 17 milliliters to titrate all 3 protons. So we're going to go over and do this in the lab. Here is the material that we've used. It's the L form of glutamic acid hydrochloride, molecular weight of 183.59. And what I've done is weighed on the analytical balance 0.5 grams of material, and we're going to transfer that to enough water to cover the electrode. We have our pH electrode previously calibrated. We'll place that on the stirring plate. We'll turn on our stir. It has a small stir bar in there. And when you do this, be sure that your electrode is fully down in the solution and the glass bulb is in the solution. We've got a half a gram of glutamate hydrochloride in about 70 or so milliliters of DI water. We'll turn that on and get it dissolved. Now, and I'm going to use a burette, a 50 ml burette, and the Vernier drop counter. Now the drop counter, you'll need the following connection here, and that comes around and goes into, I've got it into Digi 2. You could put it into DIG 1 or 2. And the pH electrode, of course, is going into channel 1, as we talked previously. So go to your computer. Once you get that set up, go to Logger Pro. Once this opens, we can begin our titration after we place the titrant in the burette. Okay. So initially we have, you would want to write this down in your logbook or keep a record of this. Initial pH then of half a gram of glutamate hydrochloride in water is 2.41, in that range. All right, and we're going to be creating volume of sodium hydroxide versus pH, and we're going to generate what's called a titration curve. So we have pH on the y-axis and volume of sodium hydroxide on the x-axis. All right, so let's go ahead and fill our burette with, I've got 0.48 molar sodium hydroxide. So be sure you have your goggles on and a good plastic funnel, and be sure the stopcock is closed. We'll go ahead and add, we don't have to fill this all the way up. We calculated 17 milliliters. We'll put a little bit more. Let's put about 25 mils of this solution in our burette. Okay. All right, we'll stop around there, just about 25 mils. We can take this out. All right. Now, one thing to do is before we begin our titration, notice we have an air bubble in our burette, the tip of our burette. So let's take this off, and we can drain that out. Sometimes the air gets trapped in there, so we can shake that. Put your finger over the top, give it a shake. There's an air bubble went up. Okay, we still have okay, so we just used about a mil or so. All right, so we still have enough to do our titration. And set this up in your burette clamp, and you want to be sure that the tip is above this slot here, and then we're going to position our stopcock so that we can turn that on and begin the drop counting. All right, so we come over to Vernier, and if everything's set up right, we can hit collect, and the data collection will begin once the titrant begins to fall through the drop counter. Now let's, before we get carried away here, let's write down our initial volume so we have a record of how much volume we're actually adding. So we're starting at 26.43, call it, 26.43 milliliters is our initial volume. All right, we're going to begin the titration. Slowly open the stopcock. And if all is well, we should start collecting data, and it is. And you could speed this up a little bit. We know we have 17 mils. Double check that the solutions are mixing. Adjust your stirring volume. And we should see a smooth titration curve. So we're seeing it's keeping track of the volume added and the pH. So we should see 3 breaks in our titration curve. I'm going to speed this up. This is the base titration of glutamic acid hydrochloride.